Then we'll start up a new part. And again, it's the standard in millimeter. Create. So now we're going to create the wheel of our valve. So we'll start off with a regular sketch. And we're going to create a circle, which is going to become the disc in the middle of the wheel. And it's to have a radius of 36, so 2 times 36 to get the diameter. And once we've set the circle, we can finish the sketch. And we can extrude it. And it's to have a thickness of 12.5 millimeters. So 12.5. $12.5. The next thing we'll do is to create a sketch on top of this disc. And now we're going to create 2 circles. So we'll set the first circle in the center. And it's going to have a diameter of 146. So 146 in diameter. Then we'll create a second circle, also attached to the center. And this one is supposed to have a radius of 86.5, so 2 times 86.5. That gives us a diameter of 173. Just zoom it out a bit so you can see everything. So once both of those circles are in place, we can click Finish Sketch. And then we're going to do an extrude. I'm just going to zoom out a bit here so we can see it properly. And we're going to extrude between those 2 circles. So we're basically creating a ring up here. And before we click OK, we have to check something. So we're going to look at it from the side, because we have to make sure that the ring is extending away from the disc. That it's not going in the same direction as the disc and covering it. And the thickness of the ring is to be 19 millimeters. So I'm just going to flip my view back here. Once that is done, we click OK. And now we're going to create a sketch that's going through the center of the ring and disc. So we're going to open up the origin folder in the browser tree so that we can see the three main planes of our coordinate system. I'm going to click Start a new sketch. And we're going to hover over the planes. We see that YZ is one of the planes that are going straight through the center like that. XZ, that's the horizontal plane, we don't want that one. And XY is also going straight through. So whether we choose XY or if we choose YZ, it doesn't really matter. Just one of those two that are going straight through our part. And this is where the F7 function comes in handy. Because now we can only see the outer part of what we've extruded. If we click F7, we can see the cross sections of them. So now it looks as though we've cut straight through the middle of our disc and ring. So in order to help us a little bit when we're going to create lines in here, we'll go up to Project Geometry. And we're going to do the drop-down menu and use Project Cut Edges. Because then it's going to show all of the edges of our part that have been cut. And it's showing them in yellow. The point of all this is that we're going to be able to sketch in one of the 6 spokes that are going to be in our wheel. I'm just going to flip it a little bit here to show you something. Along this sketch, we are going to create the outline of one of the spokes, and then we're going to extrude it symmetrically in both directions, so that we are basically centering it on this plane. But when we are extruding it then, we have a problem here because the curve of the disc is moving away from our extrusion, which means that we're going to have to make the outline of our spoke go slightly into the disc. So that we need to move it a little bit inside the disc so that it's going to be fully covered by the disc after we have extruded it. Now, as far as I know, there's no good way of doing this with just placing it in there and letting Inventor automatically figure it out. There is probably one or two advanced functions that I don't know about that's going to work and do that for me. But the best thing I know about right now is to just try a couple of times and see how far in you have to go in order to make it look good. Fortunately for you guys, I did this when I created the compendium, so I know exactly how far in I need to go. So we're just going to follow the dimensions set in the compendium when we're doing this. So I'm going to flip it back so that we can see it straight on here. So we'll start off down by the disc here, and we're going to create one line. And that line is going to start a little bit into the disc, both from the side and down from the top. And then we're just going to move it vertically down, and we're going to stop it before we reach the bottom. So over there. Then we're going to zoom out a little bit so that we can see the ring also. And we're going to move it up here, and we're going to connect it to the edge of the ring. We're going to do the same from the other end of our first line, up and connect it to the ring. Then we're also going to create a line between these two. So then we've created a full outline where we can follow it all the way around. Now we need to lock it in place somehow. So we're going to use dimensions in order to lock it in place. Just going to let you all get a chance to create the outline before we start putting dimensions on it. So the dimensions that we're going to put in place here is, first off, that we're going to have 2 millimeters from the bottom to the corner on both ends, and also from the top and to the corner on both ends. We're going to have 2 millimeters. So we'll put in a dimension constraint. I'll just start up here from the top line and down to the corner of my outline there. So the corner point. I'll put this in place and I'll put in 2 millimeters. Then I'll do from the bottom line of the ring and up to the corner of the outline. And I'll set 2 millimeters there also. Then I'll do from the bottom of the disc and up to the corner of the outline and set 2 millimeters. Now, if you are unlucky now and you get your corner on the outside of the disc, just exit the dimension function and then click on the corner and just drag it so that you get it inside again. Because if you have the corner outside here and you set a 2 millimeter dimension, then it's going to move it 2 millimeters above the disc instead. So it's important that we have it inside the disc before we set the 2 millimeter dimension on it. So then we're going to place it from the top of the disc to the corner, 2 millimeters. And now we're going to set how far into the disc we need to have this outline in order to avoid there being a gap between the disc and the outer edges of our extrude. And it's not big. All we need is a distance between the edge of the disc and to the edge of our outline. And we're going to put in 0.55. So 0.55. So just half a millimeter. That's all we need in order to get this to look good once we have extruded it. So there is still one thing we need in order to do the extrusion of our spoke, because on the outside of the ring there is supposed to be a knob in correlation with the spoke. So we're going to create a rectangle out here. So I'm just going to zoom a little bit over here. And we can use the default rectangle option, corner to corner. And I'm going to attach it to the top line of the ring. And I'm going to pull it down here. And I'm going to set it there. So we can see automatically it constrained the top line of my rectangle to the top of the disc, the ring. But it hasn't constrained the bottom one, so we need to put something on there. So we're going to do a constraint, the one that is named collinear. So we'll click on collinear constraint, and we'll click on the bottom of the ring, and then on the bottom of the new rectangle. And this locks those two into place. So now we've set the height of our rectangle. It can't change height now anymore. It has to be the same height as the ring. So now we need to set a couple of dimensions here. We'll have the inner part of the rectangle 0.55 millimeters inside here also. So from the edge of the ring to the inner part of the rectangle, and 0.55. And then we're going to have 6 millimeters from the edge of the ring and to the outer part of our rectangle. Which means that the total width of our rectangle will be 6.55 millimeters. Once you've gotten all of this in place, we click Finish Sketch. And now we're going to need to, at least in my case, I'm going to rotate it a little bit and I'm going to zoom a bit in so that we can more easily see what we're doing. So I'll rotate it over here and I'll zoom in. And then we're going to use the Extrude function. So I'll start off with the spoke itself in between the disc and the ring. And first off, we can see that it's chosen too much of the spoke, so it's extruding parts of the ring also. I don't want that, so I'm going to hold my control button and I'm going to click in here to deselect this part. Oh, then it deselected everything. Let's see. You can see here, if you let your mouse pointer hover above what you intend to extrude, you're going to get this one up after a while, and you have a drop-down menu there. And you can see that you can choose between two profile bodies. And you can't really see it all that well up here, but when I'm switching between them, this part here becomes lighted when I do the upper profile body. When I do the lower one, it's only the spoke that's lighting up. So I'll choose the lower one. That's giving me just the spoke and not the rectangle inside the ring. So I'm going to flip my view around a little bit now, just to show you what I meant about the disc curving away from our extrusion, so that it'll become a bit more clear. So as you can see up here, the 0.55 millimeters are going into the disc, but down here, where we have a straight line going, the curve of the disc is moving away from that straight line. So if we had just placed our spoke to the edge of the disc, it wouldn't really be in contact with the disc. Oops. We're also going to extrude the knob on the end there. I'm going to zoom in a bit to try to show more clearly what's being marked. I'm pretty lucky right away here. It's marking from the outer edge of the rectangle and to the inner edge of the rectangle into the ring. So I'll click on that one. Zoom like this so we can see everything. And now we have now we need to set the extrusion parameters. So we don't want it to be 19, it's supposed to be 12. So we'll set the width of it first. We'll set it to 12. But right now it's extruding it from the plane and outwards. We want it to be extruded symmetrically across the plane. So we need to switch to this option, which says symmetric. And when we click this one, it shifts the entire extrusion so that it is centered on the plane. Once we've gotten the extrusion in place, we'll click OK. And just to save some time now, we're going to place a couple of fillets. No, I'll rather show you a way of fixing it if we don't do it. So First off, we're going to do a circular pattern to put the 6 spokes out, and then we're going to show a way that how we can fix it so that we get fillets on here where we're supposed to have it. So we're going up to the circular pattern up here, just like we did for the 4 holes in the previous part. And we're going to click on our previous extrusion, and you can see it's both marking the spoke itself and also the knob. So we click on it, and then it wants a rotational axis, and then we can either click on the cylindrical side of the ring or on the cylindrical side of the disc. I'm going to zoom out a bit here so we can see everything. So here it's put previews of all the spokes, and we were supposed to have 6 spokes, so we can just leave it at 6. Once the circular pattern is in place, we'll click OK. So now we've got 6 spokes with 6 knobs on them. But we don't have all the fillets. We're supposed to have a radius of 6 on the knobs, and we're supposed to have a radius of 2 all the way around the spokes. So one way that we can fix this, the easiest thing would have been to just put the fillets on before we did the circular pattern. But every now and then you're going to make a mistake and you're going to make a pattern and you're going to figure out, damn it, I should have put that one on before I did my circular pattern. So instead of having now to select all of the edges on all 6 spokes, we can go over to the browser on the side here. And you see the lower part there which says end of part. We can click that one and we can drag it up past the circular pattern. And then the circular pattern disappears. So what we can do now, we can put our fillets in place. Then we can drag the end of part back down past the circular pattern. And then we can just edit the circular pattern and select the fillets as well. Because the circular pattern, you can only select things that are above it in the browser tree. But this is one way of editing the sequence of all the features. So what we're going to do now is to do the fillets. So we'll do the 2 millimeter ones first, and we're going to do them on the spoke. So this edge and that edge. I'm going to flip it around. And this edge and that edge. So we've got it on all 4 of the edges of the spoke, 2 millimeters. Once we've gotten the fillets in place there, we're just going to click OK. And we're going to place another fillet. And this time we're going to use a radius of 6 millimeters. And we're going to choose the outside vertical edges of the knob. So this one and that one. Six, radius of 6. So once that fillet is also in place, we're going to click OK. And now we're going to go back into our browser tree, and we're going to drag the end of part below the circular pattern again. So end of part. Drag it below the circular pattern, and whoops, we suddenly got all of our 6 spokes back again. But 5 of them don't have their fillets. So what we're going to do is to double click on the circular pattern. Make sure that you double click on the icon and not on the text, because usually you just end up changing the name of the circular pattern if you double click on the text. So click on the icon to open it up. And then we're going to go up to the Features button. So once you've gotten into the circular pattern again, you're going to click on the Features button. And we're going to move over back to the browser tree. And we're going to click on the two fillets that we placed. Fillet 1 and fillet 2. And now we can actually see them in the preview. It's put in the fillets on all of the other 5 spokes. Once that is done, you just click OK. And then your circular pattern has all of the fillets in place. And we've saved ourselves a lot of trouble with having to click on all edges of all 6 spokes. So now we're going to place a couple of more fillets, 2mm fillets. So going into the fillet part again. We're changing the radius back to 2mm, because now we're going to have the outer edges of the ring and the outer edges of the disc. All of those are going to have a 2mm radius. So one way of making this a bit faster, because if we look at the outer edge here now, it's only going to choose between each of the knobs, and then we have to choose each individual knob afterwards. If we go up to the select mode up here and click on loop, it's supposed to choose all the way around here. So it goes in a loop instead. So that means that we save a lot of clicks. We only need to click once to get it all the way around. Then we'll do the same for the other 3 edges of the ring. And also for the disc. We can't do both the disc and the ring, I think. There's something getting an error here. No, I didn't get an error. So once we've selected all of those, we're going to click OK. Now we're just missing one thing from the wheel, and that is a threaded hole in the middle with M14 threads. So we'll go up to the hole function. We'll choose the concentric option for placement. So we open up the drop-down menu and click on concentric. And the first thing we have to choose is the flat surface where we're going to drill our hole into. So that's the top or bottom of the disc in the middle. And then we need a concentric reference, and we'll just click on the edge of the disc. That's going to give us the center. Then we need to switch over to the tapped hole function in order to get threads inside our hole. So we'll click on tapped hole. And we'll switch from ANSI to isometric profile. And we have to switch the size from 3mm to 14. And that gives us M14 times 2 as our designation, but we need M14 times 1.5, which is what we have on the shaft. So we need to change the designation to 1.5 in pitch. And we can also set it to go through all, so that we have it going all the way through for sure. The problem here is if we forget to change our designation on this one to M14 times 1.5, then we'll have a different pitch on the shaft and the wheel, so that they won't match when we try to screw them together. So that would be a grievous mistake to make, because you would then produce two parts and they're not going to fit together. So you basically have to produce one of them all over again in order to make them fit. So with threads, it's very important to make sure that it's going to match up with whatever is going to be screwed into it or onto it if it's a shaft or bolt. Once you've done all of this, you click OK. And then we've managed to create our wheel. So after the break, we're going to start doing the housing for the valve, which is quite complicated. So we're probably not going to manage to make everything today, but we'll make as much as we can, at least. And we'll try to avoid the parts that we don't need for the assembly. Right, we're going to start on a new part. So we go up to the new button up in the corner. And we click create on a standard in millimeter. And now we're going to create the valve housing itself. So we've got a picture of it up here. So it looks like a basic valve. One thing that you might notice when we start going through how it's going to look like when we model it, it's not an actual valve. That's a fairly complex modeling job. So it's a simplified valve, this one. So instead of having channels where the fluid is going to move through inside, it just has a straight hole going through it. So it's not actually going to work if we produced this valve housing. But for the intents and purposes of practicing 3D modeling skills, it's valid. We're going to concentrate on the middle part here, which is the vertical part of it. We're going to create that first, and then we're just going to create the parts going off to the sides. We're not going to bother with modeling the flanges in right away. We'll see if we have time for it. We'll look at the side flanges, but we'll try to concentrate on the middle part, which is where we are going to assemble all of our other parts to next week. So we'll start a new sketch. And we'll start off by creating the flange on the top. So we'll create a circle. And it needs to be 125 millimeters in diameter. And then we'll click Finish Sketch. And we'll extrude it to a thickness of 17 millimeters. Once we've extruded that one, we'll create another sketch. And I'm going to create it on the underside of our disc, so that I'm going to extrude it downwards to create the rest of the valve. It's not a big problem if you create it on the top side. It just means that your valve will be upside down while you're modeling it. It's not going to have any significance for it when we're assembling it, so it's not a big problem. Then we're going to create another circle, attach it to the center, and this one is going to have a diameter of 60 millimeters. Once that one is done, we click Finish Sketch. And we'll click on Extrude for this one. It's going to be 130 millimeters in length. Then we click OK. So now we've gotten the middle part of our valve in place. Now we're just going to quickly create the parts that are going off to the sides, just so that we have them there in case we get time to finish the part completely. So we're going to do another sketch, but this time we have to go to the origin folder on our tree there, and we need to look for a plane that cuts through our valve like this. Once you've got a plane like that, you just click on it to start the sketch. And again, we're now creating a sketch in the middle of our part, so it is often better to press F7 to get half of the part cut away, so that it's easier to see what we're doing. We can also use project cut edges to get these yellow lines going on the outline of our part. So project cut edges, and we get it around here. Right, we're going to create the parts that are going to be extruding this way and the other way through the parts. But this is not circular. It's going to be more like a slot, because it's going to have the width of 60 millimeters, but it's going to have the height of 70. So it's still going to have a radius of 30 in the bottom and the top, but it needs to have a slightly straight portion in the middle. So in order to achieve this, we'll go over to the rectangle option and use the drop-down menu. And we're going to use one of the slot options. We know that it's going to be 70 millimeters from the outer edge to the other outer edge. So if we use this option with the overall length, we can set 70 millimeters directly. So we're going to use that one. And we're going to place it fairly close to the center here. I'm going to pull it vertically downwards and set in 70 millimeters for the length. Press the tab button to lock it in place. And just make sure that it's going vertical before we click enter. Then we're going to set the width of it, and we're going to set the width to 60 millimeters. So now we've created the slot itself with the outer dimensions, but we haven't managed to center it and put it in the correct height. So we need to do that using constraints. So I'll use a vertical constraint in order to lock it into place in the middle. I could also use the collinear constraint and lock one of the sides in place. So maybe we'll actually do that one on this one. We'll use collinear. And we'll find the part on the slot which is vertical, the straight part there. We'll click on it, and then we'll click on the yellow edge of our part there. Then it locks into place. Now we need to put the dimension in, so we need to know how far down from the top is this supposed to be. and it's supposed to be 82 millimeters down from the top, and that's from the very top of our part. So we'll click on that one, and then it will be wise to zoom in here in order to hit the correct one, because in the middle here we have 3 green dots, and it's the middle one of those dots we want to hit. So zooming in a little bit might be wise, and we're going to hit the middle of the 3 green dots. You can zoom out again and set it in here, and the length is going to be 82 millimeters. Once we've gotten this in place, we're going to click Finish Sketch. And we can now extrude the profile that we've created. So extrude, and we'll move our mouse pointer in here, and we can just see that it's lighting up the slot that we created in there. So click that one, and it's extruding it in one direction. But we want it to be symmetrical because it's supposed to go in both directions. So we're going to change it to symmetric. And the total width that we're supposed to have here is 200 millimeters, but that's including the flanges that are supposed to be on the ends there. So we're going to subtract the thickness of those flanges. So 200 minus 19 minus 19. Then we get the total width of this section of the valve. Yeah. So each of the flanges that are supposed to be on either end there is 19 millimeters wide, so we need to subtract both of those in order to get the total width of this part. Once we've put this into place, we click OK. And now we're going to create a new sketch, because now we're going to start hollowing out the vertical part here of the valve. So we're going to start a new sketch, and we need to find the plane that is going through the extrusion that we just did, along the entire extrusion there. So it's not the YZ plane in my case. It's not the XZ plane either in my case. So it has to be the XY plane. So it's going along the side here. And again, we're creating a sketch in the middle of our parts, so we'll just press F7 to get to see it a bit better. And we can click Project Cut Edges. To help us out a bit. So now we're going to do basically the same as we did with the shaft. We're going to create a center line, and then we're going to create half the outline of the drilled hole that's going to be put in here. And then we're going to use revolve, but we're going to cut instead of placing new material on it. So I'll start off with clicking on the center line option. And then I'll create a vertical line going through the center of the part. So all the way from top to bottom. Then I need to remove the center line option again, because I'm not going to create more center lines. And then we can start creating regular lines here. So now we'll try to follow the dimensions given on page 280 so that we can get the correct outline here. So I'll start off with a line up here, and it's supposed to go vertically down, but just 2 millimeters. So I'll hit 2 millimeters and lock that length into place and click enter. Then I'm going to create a horizontal line going somewhat in here. Yeah. No, we haven't made anything horizontal up there yet. Yeah, we're going to set the diameters afterwards. Yeah. So I didn't put any dimensions on the horizontal line that I just created either. We're going to set the diameters afterwards, just like we did with the shaft. The length of the next vertical line is 10 millimeters. So I lock it into place. And I'm going to make another vertical line, another horizontal line. And I'm not going to put any dimensions on that one either. Just place it in here. I'm going to pull it quite a lot down here, because this one is supposed to be 100 millimeters long. So it's going to go almost all the way down here. So I'll pull my mouse pointer quite a bit further, and then I'll write in 100. Tab button to lock it into place, and make sure that it's going to be a straight line and not at an angle. I'll place it there. 100, yes. Then we're going to create an angle line coming down here. We just have to put it fairly randomly at first. Then we're going to place another vertical line, and it's going to be 2 millimeters long. So 2 millimeters. I'm going to zoom in a bit here so we can see it a bit better. And then I'm going to create another angle line. I think I'm going to wait a bit with the last angle line just to make sure we have enough of you with us here. Uh, 210, 100. Yeah? 10. And then 100. And then a random angle line, and then 2. 100, it's the same as on page 280. But I'm just putting in the vertical dimensions right now. So, or the dimensions on the vertical lines. So the angle line doesn't get any dimension quite yet. We're going to put that one in afterwards. Yeah, the lowest down vertical line is 2 millimeters. So the next line that we're going to place is also going to be at an angle. But one thing we need to make sure of then, it's going to make our lives a bit easier, is that we don't get this, that it's locked into being parallel with the other line, because they're going to have two separate angles. So we don't want Inventor to automatically constrain it to be parallel to the other one. So we have to make sure that it's not going to be parallel. So move it off so that you don't get the parallel sign in there. Then we can place it, and we can connect it to the center line. Then we're finished placing lines for now. So what we want to do now is to place the dimensions for these angle lines so that we get all of the vertical dimensions in place. So we go up to the dimension function up here, and we'll click the top of the angle line and set the dimension down to the bottom of it. And it's supposed to be 10 millimeters. And the other vertical line is also supposed to have 10 millimeters in height. So from the top of the angle line to the bottom of the angle line, and we set 10 millimeters. Now we can start setting the diameters. So we'll start up top here. And we'll set from the first vertical line, that was 2 millimeters up there, and to the center line. And it's supposed to be 78, I think. Let's see. Just double check here. 78, yes. So 78 millimeters for that first one. For the next vertical line, we're setting the diameter of 62. So we have 78 on the top one and then 62 on the next one. Yeah. 62, yeah. So the next vertical line, the long one, is going to have a diameter of 47. I'm going to zoom out a little bit so I can see the bottom part also. And for the small vertical line between the two angled lines, it's going to have a diameter of, let's see, 39. The long line, it's 47 in diameter. Yeah. Then we have 39 on there. And then the last diameter that we're going to put in place is at the bottom here. So we're going to have to use the end of the angled line and to the center line. And it's going to be 35.5. 35.5. Yes, from the end there and to the center. Once we've gotten these in place, I just zoom out a bit so we can see everything. We can finish the sketch. And we can hit revolve. And we're going to have to be a bit careful where we're clicking here so that we actually hit the outline that we've created and not the entire outline inside the valve there. So once you hit it, you're going to see it marked in blue in there. And we're going to have to choose an axis to rotate it around, and the axis is of course going to be our center line. And we don't want to create new material in here, we want to cut material, so we need to change to the cutting option. So now we can see the preview of how it's going to create this cut in here. Once this is done, we click OK. And we now have a hole going almost all the way through our valve. So we've just got time to create the holes in the flange so that they can be connected to the flange top of our valve. So we're going to start a new sketch and we're going to click the top of our flange. And again we're going to place one single point and lock it into place with constraints. So we'll click on the point and we'll place it somewhere randomly for now. Then we're going to use either vertical or horizontal constraint, whichever fits more correctly. In my case, the vertical constraint is showing as the horizontal constraint is showing as a vertical line. But if we look at the view cube, it is also tilted 90 degrees, so that's why this is the horizontal according to the coordinate system. So I'm just going to click the point and then on the center point of the sketch so that it's going to be on a line with it. So now I can only move it up and down, I can't move it sideways. Then I'm going to set the dimension from the center point and to the new point that we've created. From the center point and to this point. And it's supposed to be, let's see, 52.1. So 52.1, and we get the location of our point. Once we've gotten a point in the correct location, we'll click Finish Sketch. And we're going to do the same as we did with the flange top. We're going to create one hole where the point is, and then we're going to use circular pattern to create 4 holes. So the first hole will be placed where our point is, but here it is very important that we don't use through all, because as you can see it's going to cut all the way through our entire valve if we do that. So we need to use the 2 option, and then we need to click on the underside of the flange. That's going to make sure that our hole is only going through our flange and not through the entire part. We also need to select clearance hole. Set it to ISO standard, and we're going to use hexagonal head cap screw. And on the flange top we had M12 bolts that we used clearance hole for, so we need to use that here also, M12. And we also used a close fit on the hole. Once we've gotten the hole in place, we can click OK. And then we can place a circular pattern with the hole. So circular pattern, we select the hole, and then we select the side of the flange as our rotational axis. And it immediately wants to place 6 holes, but we only need 4, so we switch to 4. And then we have those 4 in place. Close. Yeah. Once we click OK, we are going to get the 4 holes in place. And the hole that we've just revolved through the valve and the flange itself here, that's the important part, because this is where we're going to assemble stuff next week. So the rest of this you can do on your own if you want to, but I'm not going to bother with it. I'm going to focus on the assembly, which is what you really need to practice on, because we've only done one other practice task with an assembly, so we need to work further on the assembly. So then I need to shut down here.